All right, chapter 7, here we go. Exponential models. Okay, essential question, what is an exponential function? Well, basically it's a function where x is in the exponent. It's the power, okay? That's why it's an exponential function. You see this in your science classes when you talk about decay, like exponential decay, or you talk about half-lives, okay? If you talk about, take something like carbon or something like that, and you talk about its half-life, that means if you started with a pound of carbon today, and let's say it had a half-life of 1,000 years, if you started with a pound today, 1,000 years from now, you'd have half a pound. Another 1,000 years goes by, and you have half of the half, which means you have a quarter of a pound, and so on. Okay, that's exponential. Okay, you see, and you'll see some other things, other examples of it as we go through here. But basically, your a can't be 0. Okay, your b is going to be bigger than 0. It can't be negative. And it can't equal 1, because if it equaled 1, then 1 to any power is just 1. You just have a simple linear problem. So x is in the exponent, and what you're going to find too when we start looking at graphs of this is that the a value is where your y-intercept is. It's where you're going to cross the y-axis. Okay, and basically a basic graph of an exponential like y equals 2 to the x power. Here your a is 1, and your b is 2, and so you're going to get a graph that looks like this. And the thing about an exponential, okay, it's coming down here and it's getting oh so close to the x-axis, okay, but it never touches it. That's why we say down here that y equals 0, which is the x-axis, remember you're not going up or down, is an asymptote. An asymptote means it's just a line that we get ever so close to but we never touch. If you take that half-life deal, you know, every 1,000 years you decay a half. Technically, okay, theoretically, you never get to 0. You go from 1 to a half to a quarter to an eighth to a 16th to a 32nd. You keep taking halves. Theoretically, you never get to 0. Okay, realistically, yeah, it probably gets so small you can't see it. You think it, but we never get to 0. So this line comes down here but never touches the x-axis. And then it comes out here and all of a sudden, boom, it starts to take off. Okay, that's what exponential does for you. Okay. Growth or decay. If your b is between 0 and 1, it's a fraction between 0 and 1, then you get exponential decay and the graph goes this way. Like what we were talking about. We went from 1 to a half to a quarter to an eighth. As time goes on, this gets smaller and smaller and smaller. Okay. If b is bigger than 1, then we get exponential growth. Okay. Either way, y equals 0, the x-axis, is an asymptote. We're never going to touch it. Okay. So where do we see some of this? This formula right here models an example of exponential growth or decay. Okay, a of t, or the amount, like the amount of money in an account, okay, would equal a, your principal, what you started with, times 1 plus r, the rate that it went in at as a decimal, raised to the t power, the number of years. Okay, so there's your x, and in this case it's t, so it's raised to the t power. That's what makes it an exponential. Okay, you don't have a number yet. Well, let's look at an example. Let's say you invest $1,000 at 5% for 6 years. How much money would you have after 6 years? Well, after the amount after 6 years, a of t, t is 6. So I put in my initial amount that I started with, 1 plus my rate. Notice 5% is 0.05 as a decimal. Okay, that's what I told you here, the rate as a decimal. And then do the math. Do what's in the parentheses first. Please excuse my dear Aunt Sally. Any exponents? Yep. Take that to the 6th power, then multiply by the 1,000. If you did nothing to that $1,000 that you put in there, just put it into the account at 5%, 6 years from now you'd have $1,340.10. Okay? That's an example of exponential growth right there. So as we go into this chapter, we'll look at more of that stuff. And the exponentials will then lead into the logarithms, because those are the inverses of them. We talked about inverses at the end of chapter 6 there. So you'll see how some of that starts tying together. Okay? Exponential growth, exponential decay. We'll look at more of that as we come into class tomorrow. All right, see you then. Bye.